Can you see my screen?
Yes, doctor.
Hello? Okay, all right.
Can.
So, welcome. Okay, I have not gone through this slide yet with you. Okay, so welcome to Dynamics Topic 1, Kinematics of Particles. Okay, so now you can see these three, 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6, 7. Okay, you can see these speedboats, 7 speedboats, although you see these speedboat are very large, from a distance we can analyze their motion by considering them as a particle. Okay, all right. So when you hear the word particle, it does not mean that the particle is very small. It can be big. It can be as big as an aeroplane. Okay, all right. And then you can see a picture of a Myvi yellow car. Okay, so basically this Myvi yellow car, we can describe its position, its velocity, and its acceleration. Okay, this is what we'll be doing in dynamics. Okay, now, so engineering mechanics. So engineering mechanics is the study of how rigid or how non-deformable bodies react to forces acting on them. So we are studying uh, uh, things that are non-deformable, they are rigid. Deformable is like the slime yang adik you suka main tu. You know the slime? Slime tu kan can deform into different shapes kan, that liquid kan. So for dynamics, we do not consider things that can deform into a different shape. We consider solid things, things that are rigid and things that are non-deformable. For example, as you can see, the mouse, kan? You can see the mouse. As example, you can see the cup. All these items are non-deformable. They are rigid. Okay. Now, so previously you study statics. Okay. So what do you understand by static? Okay, maybe I can call one of your names, eh? So I want to have some two-way communication with you guys, eh? Okay. Let's call Mr. Mirza Alif. What do you understand by the study of statics last semester? Mr. Muhammad Mirza Alif.
Yes, doktor. Yang saya understand
Yeah,
dia tadi macam mana force tu react dekat benda yang tak bergerak.
I see. Okay. Are you telling me all the questions in subject statics are not moving? Tak juga
Ya,
kan?
tak
Huh?
juga.
Tak juga. So there are also some examples that are moving with constant speed. So statics, if you can see, is the study that focus on bodies either at rest. So when you said just now the word tidak bergerak, it means it is at rest. And also moving at constant speed, because you have also questions that it is moving at a constant speed. So, but in the same direction. Okay, that is the difference. It is moving at a constant speed but the same direction, or almost at rest. Okay, it means not moving. That is static. Okay, so it is very
Okey.
okay, good. Mirza, that is totally different with dynamic. So dynamic is also sometimes moving at a constant speed also, it can, but it's not in, maybe not in the same direction. Okay, or maybe the speed is not constant, it is different at different time intervals. That is dynamic, the difference. Okay, and then in static you only consider the Newton first law. The Newton first law is the equation that you always use: summation forces F equals to 0, summation forces F in X or Y or Z direction equals to 0, whereby you say the resulting force acting on the body will equal to 0. That is static. Okay, but now we're moving to hold on, hello. Now we're moving to dynamics. Okay, now so dynamic is different. It's more to the study of motion. Okay, bukan motion with the letter E, emotion. Okay, no, bukan emotion, emosi. motion, is motion. It means the study of motion means objects that are moving. You want to study the motion of that particular object. Okay, so in dynamics course, we're gonna have a study of kinematics and another study of kinetics. Okay, now what is kinematics and kinetics? As I have showed you in the plan lesson plan previously, we are going to go through particles, but there are kinematics first. So kinematics is concerned with the geometric aspect of the motion. The geometric aspect. It means, for example, they span. What is the displacement? It means first it is position here, and then all of a sudden it's position here. So the change in position means the displacement. What is the velocity of this pen, what is the acceleration of this pen, and what is the time taken for it to move from one position to another position. Everything that is considered with the geometric aspect of this particle it is kinematics. Okay, all right, is that clear? All right, so kinematics, if you can read at the bottom there, it says that kinematics does not study how motion is caused by force acting on it. It means this pen is being pushed, by a force. No, that is not kinematics. Okay, so if you have a question that a particle, for example, this pen is being pushed by a force, it does not fall under kinematics. It will fall under kinetics. Okay, are you okay, Sheikh Amma? Are you with me, Sheikh Ahmad?
Yes, yeah,
Are you
Doctor.
following?
Yes,
Okay,
yes.
good. All right, now it's very important, because I'm worried. Dynamics, to me, honestly, is very easy. But when you do not understand the difference between kinematics, kinetics, you get confused. In the end of the day, you cannot solve the problem. Okay, now let's go to kinetics. Okay, now kinetics is the study relation between the force acting on the body or the mass of the body or the body of motion. I mean this body of motion, but it uses the Newton's second law. So when you have Newton's second law, you have a force exerting on it. Okay, and the formula for Newton's second law, I think all of you are very familiar. It is F equals to ma, where m is referring to the mass in kilograms, and a is referring to the resulting acceleration, which uses the symbol a. Okay, all right. This is general about the general overview of what we're going to learn. Okay. Oops, sorry. Next slide. Okay, now for your information, we have a number of basic kinematic equations that you need to know. Okay, the basic kinematic equation are the top four that you see on the screen. Can you see the top four on the screen? Okay, let's call Nur Sabrina. Nur Sabrina tak ada?
Ada.
Ada. Nur
Yes,
Sabrina,
I
what
can
is
see
the
it.
first formula you see? Can you please speak out loud?
Is it velocity
Equals to?
equals to distance over time?
Okay, ds over dt.
Okay.
Okay, all right. Now, so the first formula is v equal to ds over dt. A equals to, second formula, A equals to dv over dt. F equals to ma, that is the Newton's second law formula. And then S equals to r theta. Okay, sorry, whereby for S equals to r theta is the equation that relates the length of an arc with its centroidal axis. Okay, but for the first chapter, that is topic 1, we're only going to consider 3 formulas, which is formula number 1, 2, and 5. Okay, Nurul Amira Ashikin, what did I say? What is the 3 first formula that we're going to use?
Formula number 1, 2, and 5.
Good, excellent. Okay, all right. So 1, 2, and 5. Okay, so those three formulas, number 1, 2, and 5, are the basic kinematic equations that we are going to use for topic kinematics of particles. Okay, all right. And then this other formula, which are formula number 6 and 7. 3 and 4 are for the other topics. Okay, throughout subject dynamics. But I'm just sharing here that these other formulas where you can see formula 6 and 7 actually comes from the basic kinematic formula. It's not a new formula that is derived on its own. It is derived from the basic. So if you notice, okay, formula number 2 and formula number 3, you get formula number 7, which is the principle of linear impulse and momentum. It's okay if you don't understand what it means now, but at least you know, oh, if I combine formula number 2 and 3 together, it means the formula of the acceleration dv over dt and the formula of Newton's second law, F equals to ma. I get the formula of principle of linear impulse and momentum. Okay, and then when I combine formula number 5, which is ADS equals to VdV, I combine with the formula number 3, I get the formula of principle of work energy. I get the formula of the principal work energy. Okay, so these are the formula, which is formula number 7 and 6. Later on, we will go through it. Okay, but at least you know what is the basic formula. Now, for formula number 5, it is actually combination of formula number 1 and 2. So if you notice here, okay, if you notice here, dt equals to ds over dv. So what I did was, um, okay, all right, dt equals to ds over dv. Okay, so what I did was I put the dt, I replaced the dt on top, and I put apa uh, I put dt on top and I put v at the bottom. Okay, for this one here, I made a mistake. As you can see, this one here, buang the value d boleh tak? You faham tak? I tersilap buat kat sini. Remove the d. It should be ds over v sahaja. Boleh tak? Hello?
Boleh,
Boleh,
boleh.
Faham I tak terlupa lah nak betulkan ni. Dah banyak kali terlupa pula nak
Boleh,
betulkan.
boleh.
Okay. Alright. So what I did is I brought the dt on top. I put the v at the bottom. Same with equation number 2. I put dt on top. I put the acceleration at the bottom. So then you will get ds over v equals to dv over a. So after that, what we do is we put it in one straight line equation. It becomes ADS equals to VdV. So this is the other equation. So again, the basic kinematic equations are equation number 1, 2, and 5. Okay, so those are the basic kinematic equations. Now, okay, when you learn kinematics of particles, you will be dealing with questions whereby the particles either it move in a straight line. So for example, this particle here, it is moving in a straight line, or this particle is moving in a curved direction. Okay, so in dynamics, you will learn how to analyze the motion of the particle when it is in a straight line or when the particle is moving in a curved direction. Okay, so for example, when the particle is moving in a curved line, rectilinear. Okay, do you know what is the term that is used when it is moving in a curved line? If it's a straight line, it's defined as rectilinear. Now, I'm asking you a question. If it's moving in a curved line, what is the term? Does anyone know? Let's try Mr. Zaki. Can you guess?
Ya, Doktor.
Can you guess what is the term if it moves in a curved line? It starts with C. Curved line.
Y equal to mx plus c.
Now,
Kan?
the term curvilinear,
Oh,
itu
okay,
je.
okay. Sorry.
Nak testing je. Okay. Alright. So when it moves in a straight line, it's called rectilinear. So when it moves in a curved line, Zaki, what is it, Mr. Zaki? I said it just now.
Curve linear.
Curvilinear.
Curvilinear.
Curvilinear. Okay, curvy. Okay, alright. Curvilinear. Okay, Curvilinear. Curvilinear. Okay, so for this class, we're only going to focus for rectilinear, whereby the path of the motion is in a straight line. Okay, so the variables that we need when we want to solve a particle that is moving in a straight line, we need the time and we need the distance along the line, and the distance along the line can be x as a function of time. Okay, and with those variables, in the end, you can find the position, the velocity, and acceleration. So again, to tell you, for this dynamic course, if you go through the whole chapter, the whole topic, you will notice that the question is the same. They will ask, find the position, find the acceleration, find the time, find the distance. It will be the same throughout the topic. Even for particles, even for rigid body, even for kinetics, will be the same. But how you decide what method or formula to use is different. For each case is different. So this case that we are going to discuss is based on rectilinear motion of particle that is moving on a straight line. Okay. So for rectilinear motion of a particle that is moving on a straight line, we will basically use the basic three formulas here. V equals to ds over dt, A equals to dv over dt, and ads equals to v dv. Okay. Now, another thing in dynamics is the technique on how you learn it. Okay, you have to be very familiar with the terms and definitions, because each term and definition means differently. The units can be different, the units can be the same, or it means differently. Okay, for example, what is the difference between position, distance, and displacement? But the units is the same. But the meaning, the units are the same, but the meaning is different. And the same with speed and velocity. You know that the speed and the velocity has the same unit, which is meter per second. But the meaning of speed and the meaning is of velocity is different. There are two different meanings. Okay, now displacement. Let's go to displacement. Okay. Let's call another name. Okay, Mr. Myor Darwishi Rushaidi. Okay, Mr. Myor Darwishi Rushaidi. Can you please read out what does displacement mean out loud? Ada dekat screen tu.
Uh, Displacement equal to change of position of an object as time changes.
So what it means in displacement is the change of position as the time changes. For example, as you can see this pen here, okay, 1 second it's here. Another 3 seconds, it's here. So the change of position, that is what you call displacement. Change in position. Okay. Same example as you can see on the screen here. So on the screen here, the ball change in position. As you can see, the dark pink into the light pink. So the change in position is what we call S prime minus S with reference to point 0 here. So that is what we call displacement is called delta S, change in position. So when people ask you what is the position, usually we say it in a scalar, in a positive scalar. It means the position is always positive value. But when we ask you what is the displacement, because displacement is change of position as time changes, it can be a quantity vector. It means the displacement can be positive or the displacement can be negative. Okay, all right. So here is just a picture of a car which is moving on the straight road. So this is what we call rectilinear motion. Here we have some soldiers marching on in a parade, but on a straight line. That is also called rectilinear motion. Okay, now, so next slide. Okay, so if the particle moves through a displacement delta s during a time interval delta t, we can say the average velocity of the particle is delta s over delta t. Okay, now, but sometimes in the question, the delta t is approaching zero. It means the time is very, very small. When the time is very, very, very small and it approaches, it approaches approaches zero, we can say that the velocity becomes instantaneous velocity. And the velocity is the time derivative of displacement. So as you can see, the velocity is time derivative of the displacement. Okay, now, so what is speed? Okay, speed is the magnitude of velocity. It has no sense of direction. It means the value of speed will always be positive because it has no sense of direction. Okay, so, okay, and speed is the total distance traveled divided by the elapsed time. Is different between velocity. Velocity is the change of position over time, but speed is the total distance traveled over time. Okay, all right. Muhammad Danish Ben Suraini, do you understand the difference between average velocity and speed? Average velocity is the average velocity is the change of position over time. But average speed is the total distance traveled over time. Okay, good. So what is total distance travel is actually the path travel and is not the same with displacement. Okay, all right. Now, the reason why I am going through with you one by one like this is I need you to really go through the lecture notes that is given to you in Evans and You Future, the lecture notes. You need to really understand the definition because by then only you can understand the topic dynamic very well. Right now I am really going to you one by one. Actually, I'm teaching the technique to show you how important is it to understand. It's not the same as, oh, I need to memorize this formula, I need to use this formula. But dynamics, you can make a big mistake when you choose the wrong formula. Understand? Okay. Now, there is a question down here. Okay, okay, see, let's say we have a ball here. Okay, this ball is moving 5 meters to the left, right, and then it returns back another 5 meters to the left. So first it moves 5 meters to the right, and then it goes another 5 meters to the left, and the time taken to travel from right to left is 5 seconds. Now, answer me this question: what is the distance travel? Okay, now, Muhammad Zulfazli bin Zainal Abidin, tell me what is the distance travel of that ball?
Distance.
Hmm. You see this ball? This ball moves right 5 meters and it returns back to its original position another 5 meters. So what is the distance travel?
Uh, 10 meters.
Yes, well done. Okay, all right. You see your name here. If you see your name here, boleh nampak tak? Your name here, lepas tu ada star. Apa tu? Zulfazli, what is it, does it say?
Sekejap, tak nampak.
Tak nampak eh? Tak nampak?
Dia blur sikit, tak nampak.
Oh, it says terrific.
Oh, okay.
Okay, lepas tu ada peace. Contoh. Tak apa. Alright, now. Belum habis lagi, Zulfazli. Okay, you dah dapat terrific star ni. You kena betul lagi 2 soalan. Your next question, Zulfazli. What is the average speed?
Sekejap. Average speed.
Okay. What is average speed, Zulfazli? The distance travel over time.
2 meter per second.
Okay, how did you calculate that?
10 meter divided by 5 seconds.
I see. So 2 meter per second. So you deserve another terrific. Okay, now if you want another terrific, you have to answer this final question, or else I will take away your terrific. So you have to earn it again for a different question. Now, what is the average velocity? Now, you have to get this correct 100%. Zulfazli, everybody is hoping on you. What is the average velocity? Now, what is the average velocity? It is the displacement, which means the distance travel. And no, sorry, is the displacement, which is the change in position divided by time.
Oh, so
Azim, tutup pintu Azim. Azim, bising dah.
I think the velocity
Answer.
is 1
Average.
meter per second.
Tak salah.
Oh,
Okay.
malah.
Does anyone here in the group knows the answer? And wants a terrific star? Who can answer me that question, please? It's okay. You can try. What is the answer? Now, what does average velocity means? Average velocity is the displacement over time. Okay, now what is displacement? Change in position. Now, first the ball moves 5 meters to the right and then it returns back to its original position. Now, what is the change in position?
Zero.
Zero.
Yes, zero. Siapa yang answer zero tu? Zaki ke? Hanif ke?
Bukan
Okay.
saya.
Hi,
Oh, okay. Masing-masing nak one terrific kan? Alright. Okay, yes, the answer is zero because finally it did not change the position because it was moving from one point to moving right 5 meters and then it returned back to its position. Okay, all right. So basically, this is very simple part of dynamics that you need to understand, and it is very, very, very what we consider very general. Okay, a very general topic. So, but this is how you understand dynamic. You need to understand the formula. You need to understand the definition. Okay, kejap eh. Tutup pintu. Okay. Okay. So what is the average acceleration? So average acceleration also equals to delta V over delta T. And when delta T is approaching zero, it becomes instantaneous acceleration. And acceleration becomes time derivative of velocity. Okay, very similar like just now. Or sometimes acceleration, you will get this formula. I'm sure you're familiar with this. D squared S over dt squared. Okay, so here you have a rocket, a picture of rocket. It is undergoing rectilinear motion. It is going shooting up to the sky. So during this time, this rocket undergoes rectilinear motion. Its altitude is a function of time and it can be measured and expressed as S equals to st. So its velocity can be found using the basic formula, kinematic formula, which is V equals to ds over dt and acceleration equals to A equals to dv over dt. Okay, so maybe you can also work at NASA. So because you know how to calculate the velocity and acceleration. you know okay, sometimes during interview question, these are the kind of questions they ask you, to see your common sense and understanding. So I hope that subject dynamics you learn it from heart. Okay, right. Now, okay, now we're going through the next slide, which is rectilinear motion with constant acceleration. Okay, now these three formulas you see in front here, these are the basic three kinematic equations that we have gone through, right? Okay, now, so three basic kinematic equations: position, velocity, and acceleration. Okay, all these three basic kinematic equations are all function of time. Okay. Now what we're going to do is we're going to look at a special case where acceleration is not changing with time and the rectilinear motion has a constant acceleration. So when we are dealing with a question that has constant acceleration or the acceleration is not changing, it means the acceleration is constant throughout. We have to derive a three new formulas. But we do not need to worry because we are deriving from the basic formula you see in front here. All right. Okay. So a good simple example that you can understand by a constant acceleration is the example of this boy here. So this boy, what he is doing, it is he is dropping the ball. Okay. So when he dropped the ball, what is happening is what you call constant acceleration. So when the ball is released, it has zero velocity, but the acceleration is constant, which is 9.81 meter per second squared. Okay, now let's look how we can derive another three basic uh, uh, equation, okay, from the kinematic equation. Now, if acceleration is constant, AC, the initial velocity is V naught and the initial position becomes S naught. Okay, V naught and S naught, it doesn't mean that V naught is 0, S naught is 0. It's just the initial, we use the symbol V naught for velocity, and the initial for position, we use the symbol S naught. Okay, from the basic kinematic equation, we can integrate and arrange it in such a way. Okay, so let's start with this middle formula here, which is A equals to dV. Okay, so A equals to dV over dt. Okay, so what we do is we bring the dt up beside A, so we will be left with dV equals to A dt, and then the symbol A, because this is for constant acceleration, we put the symbol C. Okay, so as you can see here, a dt equals dv equals to ac dt. So what symbol what is happening here? Are we integrating it or differentiating it? Nurul Amira Ashikin, are we integrating or differentiating it? Che,
Integrate.
we are integrating it. So we integrate at the left side here, dv towards v, and then at the right side here, we integrate in terms of time. Okay, so when we integrate dv, we get v minus v naught, and when we integrate dt, the time, we get act. Okay, this is integration. By now, you should be able to know how to integrate. Okay, so then when we simplify it, we bring V naught to the other side. We leave V at the left side. V will equals to V naught plus ACT. Okay, now these equations let us calculate the velocity of an object at any given time during rectilinear motion with constant acceleration. So if you have a question that you know this is kinematics of particles, it means it relates to the geometric aspect only. It is a rectilinear motion. It moves in a straight line and the acceleration is constant, and they ask you to find either the velocity, initial velocity, acceleration or time. You can use this formula. Okay? This formula. So this formula is important. But do not to worry if you do not remember it. You know you can derive from the basic kinematic equation. But usually students, they will already memorize it because they are going to use this formula a lot and many times. Okay, all right. Now let's derive the second. Okay, the second formula comes from this formula here, which is v equals to ds over dt. Okay, all right. Now let's derive it. V equals to ds over dt. The same thing. We bring dt beside v, so it will be ds equals to v dt. So we know the value of v, which is v naught plus act, which comes from formula above. So we just replace that. So we again integrate. So we integrate ds. Okay, we will get s minus s naught. We integrate this formula at this bracket, which is at this here, which is v naught plus act. We will get v naught t. We integrate it with t, time. We will get v naught t plus 1 over 2 act squared. Okay, again, we try to simplify this formula in a nice manner where we bring s naught to the other side. It becomes s equals to s naught plus v naught t plus 1 over 2 act squared. This is the formula. Okay, so when you get a question, you should identify what are the variables and what are the constants involved in the formula. Okay, all right, so you get this other formula. Next is the final formula that we need to derive to get another formula for constant acceleration. It is ADS equals to VdV. So ADS equals to VdV. We integrate ACDS based on position. We get AC equals to S minus S naught. Because acceleration is constant, so is only we can put the integration outside. So it becomes AC equals to in bracket S minus S naught. Then we integrate the velocity. We will get 1 over 2 in bracket V squared minus V naught squared and then close bracket. If you are unsure how this integration happens, you really need to try and do it by yourself, okay? All right. So again, we want to simplify this formula in a nice manner. We maintain V squared on the left side and we bring all the other formulas to the right hand side. So we will get V squared equals to V naught squared plus BC in bracket S minus S naught and then close bracket. Okay. So as you can see here, you have the three basic kinematic equation. You derive from the equation, you get an equation that can be used for constant acceleration. Okay, so this formula, these new formulas that you can see here is strictly used for rectilinear motion with constant acceleration. And these three equations are non-dependent. And you can solve with two unknowns with one set of equations. And you do not need to memorize these equations, but you need to know your constants. And you can derive by using your basic kinematic equation by setting acceleration to be constant. So these are the three basic new kinematic equation. And the three new equation, you derive from the basic kinematic equation to get the equation that can be used for constant acceleration. Okay, are you fine? Are you fine? Is that okay? Is that
Yes.
Yeah.
okay?
Yes, doctor.
Yeah.
Okay, doctor.
Okay, do you mind if we do one tutorial question? Can we do one tutorial question?
Can.
Yes.
Okay. Okay, let's do one tutorial question. Okay, uh let me just get the question for you. I need to copy this question. Okay. Okay, copy this question. The car moves in a straight line. Okay, are you copying? The car moves in a straight line such that for a short time, okay, the car moves in a straight line such that for a short time is for velocity is defined by v equals to in bracket 0.6 t square plus t close bracket meter per second. Did you get that? V equals to in bracket
No.
kosong. You didn't get that? Too fast? Or
Yeah, too fast.
V equals to 0.6 T square
Too fast.
Too fast.
Sekali lagi.
Okay. Alright. Hold on. Let me share my screen. Okay, can you see? Okay. The car moves in a straight line such that for a short time, its velocity is defined by v equals to 0.6 t square plus t meter per second, where t is in seconds. Determine its position and acceleration when t equals to 3 seconds, okay, comma, when t equals to 0, s equals to 0. Okay, are we okay? Now, let's see. Muhammad Zairi, have you finished copying?
Yes.
Muhammad Zairi. Dah habis dah. Okay. Finish copying. So now let's solve this question. Okay, now. So this question, what they ask you to do, they ask you to determine what is the position and what is the acceleration. So you want to find what is the position and what is the acceleration. Okay, now how can we solve this problem? Other choice. Okay, now we want to find the position and what we want to find the acceleration. But what we have is the velocity. We have the velocity and we have the time. Okay, now. Okay, so this is position, this is velocity, and this is acceleration. Okay, so from velocity, we want to find the acceleration. If the velocity, we want to find the acceleration, we need to integrate or differentiate. Can anyone answer?
Integrate.
Yes, integrate. If we have the acceleration and we want to find the velocity, we also must integrate. Okay, integrate. But if we have the acceleration and we want the velocity, what do we need to do?
Differentiate.
Yes, differentiate. And if we have the velocity, we want to find the acceleration, again, we need to differentiate. So now we have the velocity, but we want to find the position. What do we need to do? We need to
Integrate.
integrate. Yes. Okay. Now, I see you can do this question. Why don't you try? So, the basic kinematic equation of velocity equals to what? V equals to ds over dt. Okay. All right. So what we need to do is ds equals to v dt. So we need to integrate both sides. So let's integrate ds. So when you integrate ds, 0 to s, we need to integrate the other side. What is our velocity? Is our velocity, we already have the value. It's 0.6 t squared plus t close bracket. Okay, so this is integrate with time. Okay, all right. So the next step, when we integrate ds with 0 and s, it becomes s only. And then when we integrate 0.6 t squared plus t, what do you get? Okay. Mirza. Mirza,
Yes,
if you
doctor.
integrate, Yes, if you integrate, what do you get?
Gap.
What do you mean? Cepat sikit, what do you get?
0.3 T.
Ah, 0.3 T. When did
Oh,
you take your calculus? Last sem? This sem?
last time.
Not yet?
Last
So,
time.
macam mana integrate? 0.6
Bagi
T cube divided by 3 kan?
3.
Plus,
2 pula.
betul? T squared divided by 2. So, you akan dapat what? What do you get? Mirza?
0.2
0.2 T cube
cube
plus 0.5
T.
T. T saja?
T square.
Yes, T squared. Okay? Alright. Okay. So, the next thing that you need to do is just replace the value of T with number 3 because the question they ask you to find at the position at 3 seconds. So what do you get? Nak panggil siapa pula ni? Kita kurang ladies lah dalam ni. Kan? Siapa yang belum panggil? Kadang lupa. Danish lah. Danish, what is the answer? Use your calculator. What is the answer? Yes, Danish, excellent. I can see from the chat you have answered the question. 9.9. Danish. 9.9 S. What is it, Danish? Kalau silap, what is the answer? 9.9 what? Danish? Yes, 9.9 meters. Okay. All right, good. All right. Okay, now, can you try to find me the acceleration? So how do you want to find the acceleration now? The next question. Now, we have the velocity, but we want to find the acceleration. So what you need to do? You need to differentiate, right? Yes, good. You need to differentiate. So can you do that now? So we have let's go to the basic kinematic equation, which is A equals to dV over dt. So d over dt, what is our V? Our V is 0.6 t squared plus t. So when you differentiate this, what do you get? 1 over 2. Oh no, why I tell you the answer? I should be calling one of you. Can? Who will be my, who's going to be my victim? Okay, let's go back to Afiq. Macam tak panggil lagi je Afiq ni. Mr. Muhammad Afiq bin Muhammad. Tell me how, yes, what is the answer? How do you differentiate? Afiq?
How?
Yes, how? Dia punya how tu. How?
Nak cakap terus jawapan ke?
Terus cakap jawapan.
Sekejap,
1 point dalam sebutan T.
1.2
Apa?
T 1.2 T plus 1. 1.2 T.
Yes, excellent.
Plus 1.
Plus
betul
1.
lah, betul lah.
Okay, here you go. Another terrific star for you. Okay, alright. So 1.2 T plus 1. What unit is it, Afiq? What unit is for acceleration?
Meter per second square.
Yes, meter per second square. So all you need to do now is replace the T with 3 seconds to get the answer. So what is the answer, Afiq?
4.6 meter per second square.
Yes. Okay. All right. Now, Afiq, a bonus question for you. Why is it for this question we are not using the constant acceleration? Why aren't we using the constant acceleration formula? Can you please try to answer, Afiq? Afiq, yeah, you want this star?
Uh,
Why do you think? Why is it we are not using the constant acceleration formula here? This is important, Afiq, because when you get a question, you must decide: are you going to use the basic kinematic equation or the formula with constant acceleration? Now, why is it in this question we are not using the constant acceleration formula? Afiq, will you focus? I think your friends can answer this question. Were you here when I explained about?
yes.
Yes. Okay. Now, okay.
But
The reason why, hmm? Okay, the reason why we do not use the constant acceleration because the acceleration in this question is in the function of time. Okay, the acceleration is a function of time. It means at different time intervals, the acceleration is different. The acceleration is not constant throughout. Like if you want to use the formula for constant acceleration, it means it's suitable for normal motion. Like for example, you drop a ball, okay, then it mentioned constant acceleration. So for this question, the car is moving at a straight line. Okay, and then, but the acceleration is a function of the time. So that's why we do not use for this question the formula for constant acceleration. Okay, Afiq? Okay?
okay, madam.
Okay, all right, good. Okay, now, okay, good. Okay, now what I want to do is, okay, hold on. I'm going to share. Okay, okay, now. All right, can you see my screen now? Zaki, what am I showing now?
Huh? Albums.
What am I showing now? Huh? Huh? Okay, I'm showing
Album,
albums.
album.
Okay, now is that you need to fill in the attendance form. Now, okay, the attendance form that you need for the tutorial or for the lecture?
Lecture.
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 Okay, now you need to fill with two attendance form for live stream lecture. So you need to write down in this comment box what you have learned today. So you write down, for today's class, I learned about kinematics of particles. I learned about the difference in using formula, the basic kinematic formula, and the other formula that is using constant acceleration. And whatever you think you want to write, you can write here. Okay, I just want to understand that what lecture I have given today, you write a comment here. Okay, that is one thing. And the other thing that I need you to do is, okay, the other thing that I need you to do is, I need you to open with one ODL. Okay, now for today's class, I can only explain to you a little bit of the tutorial using the basic kinematic equation. equation. I need you to do this now. Now I need you to open this video here. Okay, and look at this video. This video, if you can see, can you see the three formulas in front of here in the video? Can you see?
Yes.
Yes, doctor.
Hello? These three equation in front of here, this is the formula for what? Is this the basic kinematic formula or the formula with constant acceleration?
Constant.
Hello?
Then.
Constant.
Yes, constant acceleration. So what I need you to do now, I need you to spend 10 minutes. This video is around 10 minutes, I think. And listen to my video explanation, the tutorial. I solved how we solve this problem that is related with constant acceleration. After that, I am going to share you this question in your Telegram for you to do. Okay, so this question is also another question that is related with constant acceleration because the rocket is experiencing a free fall motion, and also in the question it has mentioned that it is experiencing a downward acceleration of 9.81 meter per second square due to gravity. So when you read this question, you know that this question is related with constant acceleration. Before you do that question, I want you to understand this tutorial video dulu. First. So when you understand this tutorial video, you should be able to do this question. And then after that, you should also be able to go and do the other tutorial questions available that is inside these albums. Here, you just click this one, tutorial question. Okay, all right. And then you will open a tutorial question and you try to solve it. Okay, try to solve questions that are related to rectilinear motion. Here we have suggested, if it's the question is rectilinear motion, do number 11.1, 11.3 star, 11.9. Okay, so this week here, what we're doing is week 1, topic 1, kinematics of particle, rectilinear motion of particle. Okay, so this task you are given by the end of this week to do, okay, until 25th October. Okay, all right, means you can fill this attendance anytime you want according to your own flexibility. So hopefully, if you do that today, and then hopefully by tomorrow we have a class. I am going to go to week 2, which is kinematic of particles, relative motion, and several particles. Okay, we need to speed up a bit because last week we didn't really do anything much. Okay, so maybe for this week kita macam lama sikit lah. Alright, I hope that's okay. Alright, so that's it. Any questions that you would like to ask? Anything?
No, no.
No, so everything's fine, eh? So what you need to do now? You need to look at this video, right?
Yeah.
After
Yes.
this class.
Yep.
Okay? I want you to look at this video, understand it, and try to solve this question that I will send at your Telegram in a while. Okay? Alright?
Okay.
Okay.
Okay,
Okay.
doctor.
Alright. Okay,
Okay,
so
doctor.
thank you. I will see you tomorrow. Okay? So today's class is we finish around 5:19. So actually we spend about 1 hour. So I think if we maintain 1 hour, each class is fine. I think 2 hours is exhausting, but I would like you to spend time to do this on your own time. Okay. So since there is no other question,